This is example 10 of the logarithmic and exponential forms lab. We have the following expression: 2/3 log of base a of x minus 3 log of base a of y plus 3/4 log base a of z minus 4 log base a of w. We'll notice first that they're all the same base. That's important. We're going to try and condense this as much as we can using the properties of logarithms. Product rule, quotient rule, power rule, these all have to have the same bases, although power rules doesn't really have two logarithms, so it doesn't really matter. So for the product rule, we have log a of m times n is log a of m plus log a of n. Quotient rule is log a of m divided by n is equal to log a of m minus log a of n. And then the power rule is log a of m to the r is equal to r times the log of a of m. So we're going to look at our expression and see what we can do first. So we have 2/3 times log of a of x minus 3 log a of y plus 3/4 log a of z minus 4 log a of w. We'll notice first that that looks a lot like, we have all these numbers multiplied by each of their logs. That looks a lot like this right here. We have a number multiplied by log a of a thing inside. So we're going to use the power rule to put it back into this format right here, where we move this r from the front of the logarithm to the exponent. So for the first one right here, we have 2/3 times log of a of x. This is the same thing as log of a of x to the 2/3. Same thing for this. We have a minus. We have a log a of y to the third. We moved this 3 to the exponent form. Same thing for here. We have log a of z to the 3/4. It's a 4, not a 9. Okay. And then same thing for this one, where we have minus log of a of w to the 4th. So we've used the power rule to condense it a little bit. Now that we've done that, we're going to look at this, how it's subtracting and then adding and then subtracting. So that looks a lot like the product and quotient rule. So for the product rule, we have log a of m plus log a of n. The same thing as log a of m times n, and log a of m minus log a of n is the quotient rule, where we have log a of m over n. So looking at this first right here, we have a subtraction from right here, and then addition, and then another subtraction. So I'm going to use the quotient rule, where we have these subtraction problems, and put it in the fraction form right here for both these two logarithms and these two logarithms separately. So for these two logarithms here, we have log a of x to the 2/3 minus log a of y to the third. That's going to be the same thing as log a of x to the 2/3 will be our numerator over y to the third. So that's the quotient rule, where you have this minus this with the same base. This is the numerator, this is the denominator. So now for this one, this is going to tack on this plus. Log a of z to the 3/4 minus log of a to the w4. This will be the numerator, this will be the denominator. It's the same thing as log of base a of z to the 3/4 over w to the 4th. Like that. Now we'll notice that they have the same base throughout all of it, so we can use the product rule here because they're being added. So the product rule here, log a of m plus log a of n, we can rewrite this as log a of m times n. So these things will be multiplied. So this is the same thing as log of base a of what's inside here multiplied by here when we multiply fraction across. So this will just be x to the 2/3 times z to the 3/4 all over y to the third times w to the 4th. Like that. The last thing we can do, this is pretty condensed, but the last thing we can do is write these exponents in radical formation. So we have log of 2/3 z of 3/4. We can rewrite that as log of a, and x to the 2/3 is the same thing as a radical of 3, or x is squared. And z to the 3/4 is the same thing as the radical of 4, where we have z to the cubed over y cubed w to the 4th. And we cannot combine these radicals because they have a different number here, as you can see. And this is as condensed as we can get this expression.